Silver processing involves several stages, from mining the raw ore to refining the metal into its pure form for industrial and commercial use. Here's an overview of the process. 1. Mining silver. Silver is primarily found in ores such as argentite, ages, chlorgerite, horn, silver, and as a byproduct in the mining of lead, zinc, copper, and gold. The two main mining methods are open pit mining, used when silver ore is near the surface; underground mining, used for deeper deposits. 2. Crushing and grinding. Once mined, the ore is crushed into smaller pieces to facilitate the extraction of silver. It is then ground into a fine powder to increase surface area for processing. 3. Concentration of silver. Silver is often found mixed with other minerals, so it must be concentrated. The main methods include flotation. Chemicals are used to make silver-bearing minerals float, while unwanted materials sink. Gravity separation uses differences in density to separate silver from other materials. 4. Extraction of silver. There are several ways to extract silver from ore: cyanidation, heap leaching, or agitation leaching. The powdered ore is mixed with a solution of sodium cyanide, which dissolves the silver. Zinc is added to the solution to precipitate the silver out. The resulting material is smelted to extract metallic silver. Amalgamation, historical method. Mercury was used to dissolve silver, but this method is mostly obsolete due to environmental concerns. Smelting for high silver ores. The ore is melted in a furnace, and silver separates from impurities. Lead reduction Parks process for lead ores. If silver is found in lead ores, molten lead is treated with zinc, which extracts the silver. The silver-zinc alloy is then heated to remove the zinc. 5. Refining silver. To obtain pure silver, the extracted silver must be refined. Common methods include electrolytic refining. Silver is placed in an electrolyte bath, and an electric current removes impurities, leaving pure silver. Fire refining cupellation. Silver is melted, and impurities are oxidized and removed as slag. Chemical refining. Silver is dissolved in nitric acid and then precipitated out using copper. 6. Final processing and uses. The refined silver is cast into bars, coins, or granules for industrial use. Silver is used in jewelry and silverware, electronics and batteries, photography historically, medicine and antimicrobial applications, mirrors and solar panels, coinage and investment. Sure, let's go deeper into each stage of silver processing, from extraction to final applications. 1. Mining silver. Silver is rarely found in its pure form in nature. Instead, it exists as part of mineral compounds or as a byproduct in mining other metals like gold, lead, zinc, and copper. The main sources of silver include argentite, ages, a silver sulfide mineral; chlorgerite, also known as horn silver; galena, PBS, a lead sulfide or that often contains silver; native silver, pure silver in natural form, though rare. Mining techniques. Open pit mining, used for near-surface deposits, involving excavation and removal of large quantities of rock. Underground mining, used for deeper veins, where tunnels and shafts are built to extract the ore. Once the ore is mined, it is transported to a processing facility. 2. Ore crushing and grinding. Before silver can be extracted, the ore must be crushed and ground into fine particles. This increases the surface area of the material, making chemical reactions more efficient. Jaw crushers and cone crushers break large chunks of ore into smaller pieces. Ball mills and rod mills grind the crushed ore into a fine powder. 3. Silver ore concentration. The next step is to separate silver-bearing minerals from waste rock gangue. The concentration methods depend on the type of ore. Flotation. This is the most common method for extracting silver from sulfide ores. The ore is mixed with water and chemicals, creating a slurry. Air bubbles are introduced, and the silver-rich particles attach to the bubbles and float to the surface. The silver-rich froth is skimmed off and further processed. Gravity separation uses the density differences between silver-bearing minerals and unwanted materials. Spiral concentrators, shaking tables, or centrifugal concentrators are used for extraction of silver. After concentration, silver must be chemically or thermally extracted from the remaining material. Cyanide process, heap or tank leaching. This is the most widely used method for low-grade silver ores. Crushed ore is stacked in heaps or placed in agitation tanks. A dilute cyanide solution is added, dissolving the silver into a liquid solution. Zinc powder is introduced. which causes silver to precipitate out as a solid. Silver is collected and smelted into a higher purity form, smelting. For high silver ores, the ore is melted at high temperatures, above 10 degrees Celsius, or 1832 degrees Fahrenheit. A flux such as borax is added to remove impurities. The molten silver is separated from slag and cast into bars. Parkes process for silver in lead ores. Molten lead containing silver is treated with zinc, which forms a silver-rich alloy. The alloy is skimmed off, and the zinc is removed by heating, leaving behind pure silver. Cupellation traditional refining. The lead-silver alloy is heated in an oxygen-rich environment. Lead oxidizes and is absorbed into the furnace lining, leaving pure silver behind. 5. Refining silver. To obtain high-purity silver, 99.9% or higher, further refining is required. Electrolytic refining. The impure silver is placed as an anode in an electrolytic cell. A silver nitrate solution is used as the electrolyte. Pure silver is deposited onto a cathode, while impurities settle as sludge. Chemical refining. Silver is dissolved in nitric acid to create silver nitrate. Copper or another reducing agent is added, causing silver to precipitate out. The silver is then melted and cast into bars. 6. Final processing and uses of silver. Refined silver is formed into various products, depending on its intended use. Forms of processed silver. Bullion bars and coins. Used in investment and reserves. Granules and powder. For industrial applications. Wire and sheets. Used in electronics and jewelry. Common applications of silver. Jewelry and silverware. Due to its luster and durability. Electronics. Silver is a superior electrical conductor, used in circuits, semiconductors, and batteries. Photography, historical use. Silver nitrate was used in film development. Medicine and antibacterial uses. Silver has antimicrobial properties used in wound dressings and medical devices. Mirrors and optics. Silver's reflective properties make it ideal for mirrors and telescopes. Solar panels. Silver paste is used in photovoltaic cells to enhance energy absorption. Coinage and investments. Many countries produce silver coins for collectors and investors. Environmental considerations in silver processing. Cyanide management. Cyanide solutions must be carefully managed to prevent contamination. Water use and recycling. Processing uses a lot of water, requiring treatment and recycling efforts. Mine tailings management. Leftover materials must be stored properly to avoid pollution. Let's go even deeper into each stage of silver processing, exploring advanced details, historical context, and modern technological developments. 1. Mining silver or silver mining has evolved significantly over time. Historically, civilizations such as the Greeks, Romans, and Spanish extensively mined silver, often using manual labor and primitive smelting techniques. Today, modern technology allows for more efficient extraction. Types of silver deposits. Primary silver deposits. These contain silver as the main valuable metal, often in minerals like argentite ags, chlorogyrite, agate and native silver. Byproduct silver deposits. Most of today's silver production comes from mines where silver is extracted alongside lead, zinc, copper, or gold. Advanced mining techniques. Cut-tan fill mining used in high-grade underground silver mines. Miners extract ore in layers, then backfill the empty spaces for stability. Block caving, used in large low-grade silver deposits. This method allows the rock to collapse under its own weight, making ore extraction more efficient. Hydraulic mining historical. This method, used in the 19th century, involved washing silver-bearing soil with high-pressure water, but it caused severe environmental damage and is now banned in many places. 2. Crushing and grinding the ore. Once the ore is extracted, it must be broken down for processing. Crushing process. Large rocks are fed into jaw crushers or gyratory crushers, breaking them down to smaller pieces. Secondary crushers, such as cone crushers, further reduce the size. Grinding process. The ore is placed into rod mills, or ball mills, where heavy steel rods or balls, grinded into fine powder. Autogenous grinding AG and semi-autogenous grinding SAG. In some modern mining operations, large mills grind the ore using its own rock fragments to reduce energy consumption. 3. Silver or concentration. Concentration is essential to remove waste materials and isolate the silver-bearing minerals. Froth flotation. The most common method, Ore is mixed with water and reagents, collectors, frothers, and modifiers to form a slurry. Air is introduced, creating bubbles that attach to silver-rich particles. The silver-rich froth is skimmed off, while waste material sinks. The concentrated silver material is dried and prepared for further processing. Other concentration methods. Magnetic separation. Used when silver ore is associated with magnetic minerals. Gravity separation. Spiral concentrators and shaking tables separate heavier silver minerals from lighter waste. For extracting silver from ore. Different ores require different extraction methods. Cyanide leaching, most common for low-grade ores. Used in both heap leaching and agitated tank leaching. Cyanidation dissolves silver into a solution. Heap leaching. Silver ore is crushed and piled onto a lined pad. A cyanide solution is dripped through the heap, dissolving silver as it trickles down. Tank leaching. Crushed ore is placed in large tanks, where cyanide is mixed with oxygen to dissolve the silver. After dissolution, zinc powder precipitation Merrill-Crowe process. Zinc powder is added, forcing silver to precipitate out of the solution. Activated carbon adsorption SIP and CIL processes. Silver is absorbed onto activated carbon and later stripped off using high-temperature chemical solutions. Smelting used for high-grade silver ores. Roasting sulfide ores are heated with oxygen to produce silver oxides. Reduction. The oxides are then heated with carbon or other reducing agents to extract pure silver. Flux addition. Fluxes such as silica and borax help remove impurities during melting. Slag removal. Impurities float to the top and are removed as slag, leaving pure molten silver. Parks process. For silver and lead ores, molten lead is treated with zinc, which absorbs the silver. The silver-zinc alloy is skimmed off and further refined through distillation. Zinc is vaporized, leaving behind purified silver. Amalgamation, a historical process. Mercury was used to dissolve silver, forming an amalgam. The mercury was then vaporized, leaving behind silver. Banned due to environmental toxicity. 5. Refining silver. Silver extracted from ore usually contains impurities, such as gold, copper, and lead. Refining methods include electrolytic refining, the most efficient method. Impure silver is placed as an anode in a silver nitrate bath. Electric current is applied, causing pure silver to deposit onto a cathode. Impurities fall to the bottom as sludge, which can contain valuable metals like gold. Fire refining used when silver is alloyed with lead or other base metals. The alloy is heated with air, oxidizing lead and other impurities, leaving pure silver behind. Chemical precipitation. Silver is dissolved in nitric acid, forming silver nitrate (OGN). Adding copper causes the silver to precipitate out as a powder. The silver is washed, melted, and cast into bars. 6. Final processing and industrial uses of silver. Refined silver is cast into different forms depending on its intended application. Common forms of silver. Silver bullion bars and coins. For investment and reserves. Silver powder and granules. Used in industrial and chemical applications. Silver wire and sheets, used in jewelry and electronics. Industrial and technological uses of silver. Electronics, used in printed circuit boards, PCBs, electrical contacts, and connectors due to its high conductivity. Solar panels. Silver paste improves energy efficiency in photovoltaic cells. Medical applications. Silver's antimicrobial properties make it useful in wound dressings, medical instruments, and even water purification. Mirrors and optics. Silver coatings create highly reflective surfaces for telescopes and high-end mirrors. Batteries. Silver oxide batteries are used in watches and small electronic devices. Cultural and monetary uses. Silverware and jewelry. Used for thousands of years due to its luster and durability. Coinage. Historically used as currency, and still minted in some countries for collectors and investors. 7. Environmental considerations and sustainability in silver processing. Silver mining and refining can have significant environmental impacts. Cyanide management. Cyanide must be neutralized before being discharged. Detoxification methods include the INCO process, where cyanide is broken down into carbonates and nitrates. Water recycling. Modern silver processing plants recycle water extensively to reduce waste. Mine tailings and waste management. Tailings leftover rock and chemicals. must be stored safely to prevent contamination. Some companies are exploring tailings reprocessing to extract leftover silver. Sustainable silver mining. Some companies are adopting bioleaching, using bacteria to extract silver. To reduce chemical use. Urban mining is growing, where silver is recovered from e-waste, phones, computers, etc. Processing silver into jewelry. From raw metal to finished pieces. Silver jewelry making is a meticulous process that involves refining, alloying, shaping, and finishing the metal to create beautiful, durable pieces. Below is a detailed step-by-step guide on how silver is processed and transformed into jewelry. 1. Refining and alloying silver. Before silver can be used for jewelry, it must be purified and alloyed to enhance durability. Refining silver to high purity 99.9%. Electrolytic refining, the most efficient method, using an electric current to separate pure silver from impurities. Cupellation fire refining, used when silver contains lead or other metals, removing them by oxidation. Alloying silver for strength and durability. Pure silver, 99.9%, is too soft for most jewelry, so it is mixed with other metals to improve hardness. Sterling silver, 92.5% silver, 7.5% copper, the most common silver alloy used in jewelry. Argentium silver 93.5% or 96% silver plus germanium, a tarnish-resistant silver alloy. Fine silver 99.9% silver, used for high-end jewelry but is more prone to scratches. 2. Designing and creating silver jewelry. Once the silver is ready, artisans or manufacturers use different methods to shape and craft jewelry. Handcrafted jewelry, traditional and artisanal. Design sketching. Jewelry makers sketch ideas to visualize the final piece. Wax carving. Lost wax casting. A wax model of the jewelry is created, which will later be replaced with molten silver. Hammering and shaping. Thin silver sheets or wires are shaped into jewelry using hammers and anvils. Modern manufacturing methods. Computer-aided design CAD and 3D printing. Digital models are created before production. Casting. Lost wax method. A mold is made from wax, filled with molten silver, and then cooled to form the piece. Stamping and pressing. Thin silver sheets are cut and stamped into designs for mass production. 3. Silver casting and shaping techniques. There are several techniques used to shape silver into jewelry. Lost wax casting. A wax model of the jewelry is made. The wax model is covered in a plaster-like investment material. The wax is melted out, leaving a hollow mold. Molten silver is poured into the mold. Once cooled, the mold is broken, revealing the silver piece. Hand fabrication. Traditional silversmithing involves cutting, shaping, and soldering silver sheets and wires to form jewelry. Hammers, saws, and pliers are used to shape metal manually. Die striking for mass production. Silver sheets are stamped with high pressure using a custom die to cut out shapes and patterns. Electroforming for hollow and lightweight jewelry. Silver is deposited onto a mold using an electric current, forming a thin silver shell. 4. Soldering and assembling silver jewelry. Once the basic shape is created, different parts of the jewelry are joined together. Silver soldering using a high-heat torch to fuse pieces together. Riveting, a cold connection technique using small metal pins, instead of soldering. 5. Stone setting and engraving. Jewelry is often adorned with gemstones, engravings, or decorative patterns. Gemstone setting techniques. Bezel setting. A metal rim encircles the gemstone. Prong setting. Small metal claws hold the stone in place. Setting. Multiple small gemstones are embedded closely together. Engraving and embossing. Hand engraving creates intricate patterns. Laser engraving is used for precision and mass production. 6. Polishing and finishing silver jewelry. After assembly, the jewelry undergoes several finishing steps to enhance its appearance. Polishing and buffing. Silver is polished using rotary polishing machines or handheld tools. Different abrasives remove scratches and create a mirror-like finish. Oxidation and antiquing. Some silver jewelry is intentionally darkened using liver of sulfur to create contrast in designs. Plating and coating for protection and aesthetics. Rhodium plating, applied to silver jewelry to prevent tarnish and enhance shine. Gold or rose gold plating. Silver jewelry is coated with a thin layer of gold for a luxurious appearance. 7. Quality control and stamping. Before jewelry is sold, it undergoes quality checks and is marked with official stamps. Quality control. Jewelry is inspected for defects, scratches, or weak soldering points. Gemstones are checked for secure settings. Hallmarking silver purity stamps. Most countries require silver jewelry to be stamped with a hallmark indicating its purity. 925 sterling silver. 999 fine silver. Makers' marks and country codes may also be included. 8. Packaging and distribution. Once completed, silver jewelry is packaged and distributed for sale. Luxury brands package jewelry in high-end boxes with certificates of authenticity. Mass-market jewelry is often sold in simple pouches or cases. 9. Caring for silver jewelry. Silver jewelry requires maintenance to prevent tarnishing. Storage. Keep silver in anti-tarnish pouches or airtight containers. Cleaning. Use silver polishing cloths, baking soda, or commercial silver cleaners. Avoid chemicals. Exposure to perfume, lotions, and chlorine can accelerate tarnishing. Complete guide to silver jewelry processing. From raw metal to masterpiece. Silver jewelry production is a highly skilled process that combines ancient craftsmanship with modern technology. Below is an in-depth guide covering every aspect of transforming raw silver into stunning jewelry. 1. Silver refining and alloying. Before silver can be shaped into jewelry, it must be refined to remove impurities and alloyed to improve durability. Refining silver to high purity 99.9%. Electrolytic refining. Silver is dissolved in silver nitrate and purified through electrolysis, where pure silver collects on a cathode. Cupellation, fire, refining. Used for ores containing lead. This process heats silver and oxidizes unwanted metals, alloying silver for jewelry. Pure silver, 99.9%, is too soft for everyday wear, so it's mixed with metals like copper, germanium, or platinum to enhance strength. Sterling silver, 92.5% silver, 7.5% copper. The most popular silver for jewelry, strong yet workable. Argentium silver, 93.5% or 96% silver, plus germanium, more tarnish resistant than traditional sterling silver. Fine silver 99.9% used for high-end jewelry but softer and more prone to scratches. 2. Designing the jewelry. Before silver is shaped, a detailed design is created. Traditional hand-drawn designs. Artisans sketch designs to determine shape, proportions, and gemstone placement. Computer-aided design CAD. Digital 3D modeling allows jewelers to create highly precise and complex designs. Designs can be 3D printed into resin models for mold making. 3. Silver jewelry manufacturing techniques. Several techniques are used to shape silver into jewelry, depending on the design and production scale. A. Casting methods. 1. Lost wax casting, most common. A wax model is made and coated with investment material, plaster-like. The wax is melted out, leaving a hollow mold. Molten silver is poured into the mold and cooled. The mold is broken, revealing the silver piece. The jewelry is cleaned and polished. 2. Sand casting for unique, textured pieces. A design is pressed into fine sand, creating a mold. Molten silver is poured in, capturing the texture of the sand. 3. Decasting for mass production. Molten silver is injected into a steel mold under high pressure. Used for producing identical jewelry pieces quickly. B. Hand fabrication, traditional silversmithing. Silver sheets and wires are cut, hammered, and soldered into shape using tools like rolling mills. Flatten silver into sheets, saws and files. Shape silver into delicate patterns. Mandrels and stakes form rounded shapes for rings and bracelets. Hammers and anvils create textures and unique shapes. C. Stamping and pressing. Used for lightweight and affordable silver jewelry, where a hydraulic press stamps designs onto thin silver sheets. D. Electroforming for hollow and lightweight jewelry. Silver is deposited onto a conductive mold using an electric current. This process creates hollow silver pieces that are lightweight but sturdy. 4. Soldering and assembling the jewelry. Silver soldering, joining pieces together. A blowtorch and silver solder are used to fuse metal parts. Laser welding provides ultra-precise soldering, often used for high-end jewelry. Riveting and cold joining. Mechanical fasteners rivets are used instead of heat. 5. Stone setting and engraving. Jewelry often features gemstones or decorative carvings. Stone setting techniques. Bezel setting. A thin metal band encircles the stone. Prong setting. Small metal claws hold the gemstone. Channel setting. Stones are set between two strips of silver. Setting, tiny gemstones are embedded closely together. Engraving and embossing. Hand engraving. Artisans use chisels to carve intricate patterns. Laser engraving. Creates detailed designs quickly and precisely. 6. Polishing and finishing silver jewelry. Raw silver pieces must be refined for a smooth and flawless finish. Polishing methods. Buffing wheels. High-speed wheels remove scratches and imperfections. Tumbling with abrasives. Jewelry is placed in a tumbler with polishing media, ceramic, steel, or plastic beads. Hand polishing. Cloth and silver polish are used for fine details, surface treatments and textures. Matte or satin finish. Gives silver a soft, brushed look. Hammered finish. Creates an artisanal, textured effect. High polish finish. A mirror-like reflective surface. 7. Tarnish prevention and coatings. Silver is prone to oxidation tarnishing, so coatings are applied to protect the metal. Common protective coatings. Rhodium plating. A thin layer of rhodium is electroplated for a bright, tarnish-resistant finish. Anti-tarnish lacquers. Clear coatings prevent oxidation. Oxidized silver, intentional darkening. Liver of sulfur is used to create contrast and depth. 8. Quality control and hallmarking. Every piece of jewelry undergoes rigorous testing before being sold. Quality control inspections. Checking for defects, looking for cracks, weak joints, or uneven polishing. Gemstone security. Ensuring stones are firmly set. Durability testing. Stress testing pieces to check for breakage. Hallmarking and stamps. Silver jewelry is marked with a purity stamp to verify its authenticity. 925. Sterling silver. 92.5% pure silver. 999. Fine silver. 99.9% pure silver. Maker's mark identifies the jewelry's manufacturer or artisan. 9. Packaging and distribution. Once finished, silver jewelry is prepared for retail sale or custom orders. Packaging styles. Luxury packaging. Velvet boxes, silk pouches, or wooden cases. Eco-friendly packaging. Recycled paper boxes and biodegradable bags. Sales and distribution channels. Luxury jewelry boutiques, high-end stores for exclusive silver jewelry. Online stores and marketplaces, Etsy, Amazon, and brand websites. Wholesale and mass retail, sold in bulk to department stores. 10. Caring for silver jewelry. Proper care helps maintain the beauty and longevity of silver jewelry. Storage tips. Store in anti-tarnish cloths or airtight bags. Keep away from moisture to prevent oxidation. Cleaning silver jewelry. Polishing cloth. Gently buffs tarnish off. Baking soda and aluminum foil. A homemade silver cleaning method. Ultrasonic cleaners. Used for deep cleaning intricate jewelry. It looks like you want even more details on silver jewelry processing. Let's go deeper into each stage, including historical methods, cultural significance, advanced techniques, and future innovations in silver jewelry making. 1. Origins and history of silver jewelry making. Silver has been used for thousands of years to create jewelry, with techniques evolving across civilizations. Ancient silver jewelry pre-000 BCE. Mesopotamians 3000 BCE created silver beads and rings using basic hammering techniques. Egyptians 2000 BCE used lost wax casting and filigree to craft elaborate silver necklaces. Greeks and Romans 500 BCE to 300 CE mastered engraving and hammered relief designs. Medieval and Renaissance silver jewelry 500 CE to 1600 CE. Vikings 800 to 1100 CE created silver arm rings and brooches with knotwork designs. Mughal Empire 1500s developed intricate silver inlay techniques with gemstones. Industrial Revolution and modern silver jewelry 1800s present. 1800s. The rise of mechanical presses allowed mass production of silver jewelry. 1900s. Art Nouveau and Art Deco movements introduced flowing and geometric silver designs. Today, jewelry is made using AI-assisted CAD, 3D printing, and eco-friendly silver refining. 2. Advanced silver refining and alloying. Beyond traditional refining, modern technology has improved how silver is purified and strengthened. Eco-friendly silver refining. Bioleaching uses bacteria to extract silver from ores without toxic chemicals. Electrolytic recycling extracts silver from industrial waste and old jewelry. Specialized silver alloys. Titanium silver sterlium plus, stronger and tarnish resistant. Platinum silver adds durability and a bright white metal finish. Flexible silver, a new bendable silver alloy for adjustable jewelry. 3. Design and 3D modeling innovations. Modern jewelry design has evolved beyond hand sketches into AI-powered and 3D rendered models. AI-driven design trends. AI suggests custom silver jewelry designs based on user preferences. AI-generated parametric designs create unique geometric patterns. 3D printing silver models. Resin 3D printing creates ultra-precise models for lost wax casting. Direct metal 3D printing uses laser sintering to print solid silver jewelry. For cutting-edge silver jewelry manufacturing techniques, hand fabrication, high-end artisan, silver work. Granulation, ancient technique where tiny silver beads are fused onto jewelry. Filigree, thin silver wires are twisted and soldered into delicate lace patterns. Metal is hammered from behind to create raised reliefs. Modern casting methods. Centrifugal casting uses spinning force to ensure silver fills even the finest details. Vacuum casting uses suction to pull molten silver into molds for complex designs. Micro-welding for precision silver jewelry. Laser welding joins small silver components with extreme accuracy. Pulse arc welding used for repairing and joining fragile silver pieces. 5. Gemstone setting innovations. New technologies allow stronger and more precise settings for diamonds, emeralds, opals, and sapphires. Automated stone setting. Robotic precision, AI-controlled machines can set 100+ gemstones per hour. Microscopic laser setting uses lasers to set micro-PAV-O diamonds in silver bands. Invisible setting, modern technique. Gemstones are held without visible prongs or bezels, giving a floating effect. 6. Advanced finishing and tarnish prevention technologies. Silver is prone to oxidation, but new nano-coatings and plating methods extend its lifespan. Next-gen anti-tarnish solutions. Nanotechnology coatings apply molecular layers to prevent oxidation. Ceramic sealing, a thin, clear ceramic layer prevents scratching and tarnishing. Plating and surface treatments. Palladium plating, more durable than rhodium, for tarnish-proof silver jewelry. Black rhodium and oxidized silver, used for Gothic and antique-style silver jewelry. 7. Future of silver jewelry. Smart and interactive designs. Jewelry is evolving beyond fashion into wearable technology. Smart silver jewelry. Silver RFID rings and bracelets. Unlock doors, make payments, or store medical data. Mood-responsive silver jewelry. Uses thermochromic materials that change color based on temperature. Sustainable and ethical silver jewelry trends. Lab-grown silver crystals. Environmentally friendly silver grown using recycled silver jewelry. Old jewelry is melted down and reworked into new designs. 8. The cultural and symbolic meaning of silver jewelry. Silver is deeply rooted in culture, symbolizing wealth, protection, and spirituality. Silver in ancient cultures. China, silver was used for spiritual protection and wedding jewelry. Mexico, home to Taxco silver jewelry, known for its bold and intricate designs. Native American tribes crafted turquoise inlaid silver jewelry for spiritual ceremonies. Silver as a healing metal. Silver has antibacterial properties, used in healing rings and bracelets. Silver is believed to enhance intuition and is often worn by spiritual practitioners. 9. The business and market trends of silver jewelry. The silver jewelry industry is constantly evolving, driven by fashion, technology, and sustainability. Global demand for silver jewelry. India and China are the largest consumers of silver jewelry. Sustainable and recycled silver jewelry is growing in popularity. Custom and personalized silver jewelry is dominating online marketplaces like Etsy and Instagram. Luxury versus affordable silver jewelry markets. Luxury silver brands like Tiffany & Co. and Pandora focus on designer high-polished silver. Affordable brands like Etsy artisans and fast fashion retailers offer handcrafted or trendy silver jewelry. Conclusion: the timeless future of silver jewelry. Silver jewelry making has evolved from ancient techniques to futuristic innovations like 3D printed and smart silver jewelry. With sustainable practices, cutting-edge technology, and deep cultural significance, silver remains one of the most beloved materials for jewelry worldwide. Historical silver jewelry styles and futuristic trends. Silver jewelry has deep cultural roots spanning thousands of years. evolving from ancient spiritual amulets to high-tech smart accessories. Below is a detailed timeline of historical silver jewelry styles, followed by an exciting look at futuristic trends shaping the industry. Historical silver jewelry styles ancient to modern. 1. Ancient silver jewelry, 3000 BCE. 500 Mesopotamian silver jewelry, 3000 to 1500 BCE. One of the first civilizations to use silver in rings, necklaces, and headdresses. Silver beads were strung into elaborate collars worn by royalty. Ancient Egyptian silver jewelry 2000 to 500 BC. Though gold was more common, silver was used for scarab amulets, signet rings, and religious jewelry. Hathor's silver headdress burial item symbolized divine protection. Greek and Roman silver jewelry 500 BCE to 500 CE. Greeks created delicate filigree silver earrings and laurel wreath diadems. Romans developed engraved silver signet rings, brooches, and coin jewelry. 2. Medieval and Renaissance silver jewelry 500 to 1600 CE. Viking silver jewelry 800 to 1100 CE. Used for status and trade, including silver arm rings, brooches, and pendants with Norse runes. Found in Viking hoards buried as treasure. Islamic and Mughal silver jewelry 900 to 1600 CE. Islamic artisans perfected silver inlay work, creating calligraphic pendants and Quranic rings. Mughal India combined silver with precious stones and highly detailed filigree jewelry. European Renaissance silver jewelry 1400 to 1600 CE. Nobility wore silver necklaces with religious medallions and intricate silver chainmail belts. Cameos and lockets became popular, often engraved with personal messages. 3. Baroque to Victorian silver jewelry, 1600 to 1900 CE. Baroque period 1600 to 1750 CE. Extravagant silver jewelry featured curved, floral, and lace-like patterns. Chokers, bodice ornaments, and jeweled crosses were worn by European aristocracy. Georgian and Victorian silver jewelry 1700 to 1900 CE. Georgian era 1700s, handmade silver tiaras and brooches with nature motifs. Victorian era 1800s, rise of mourning jewelry, lockets, and silver hairpins. Taxco silverwork Mexico, late 1800s, crafted by artisans in ornate, symbolic patterns. For Art Nouveau and Art Deco silver jewelry, 18901940 CE. Art Nouveau, 1892-1915 CE, inspired by nature, featuring curved silver vines, floral motifs, and fairies. Handcrafted pieces with soft, flowing lines and silver filigree. Art Deco 1920s-1940s CE, geometric and bold designs inspired by Egyptian and Aztec motifs. Sterling silver cuff bracelets and long, dangling earrings. Machinage influence led to precise, angular 5 mid-century modern, 2 contemporary silver jewelry, 1950s present, 1950s-1980s. The era of mass production. Scandinavian silver jewelry became famous for its minimalist, organic forms. Southwestern Native American, silverwork Zuni and Navajo, gained popularity worldwide. 19. Handmade and sustainable silver jewelry. Revival of handcrafted silver techniques, granulation. Eco-friendly silver recycling and lab-grown gemstones. 2. Futuristic trends in silver jewelry 2025 and beyond. 1. Smart silver jewelry wearable technology. RFID and NFC silver rings. Unlock doors, make payments, and store digital IDs. Mood sensing silver jewelry. Changes color based on temperature or emotions. Health tracking silver bracelets. Monitors heart rate, hydration, and stress levels. 2. AI and 3D printed silver jewelry. AI-generated custom designs. Smart software analyzes personal tastes to create one-of-a-kind silver pieces. 3D printed silver jewelry. Direct metal printing allows for impossibly intricate, futuristic designs. Parametric jewelry designs. Using algorithmic patterns to generate unique silver structures. 3. Sustainable and ethical silver jewelry. Recycled silver jewelry. Old silver is melted and repurposed into new pieces. Lab-grown silver crystals. Using controlled environments to grow silver structures without mining. Blockchain authentication ensures transparency in sourcing and production. For color-changing and light-emitting silver jewelry. Electrochromic silver jewelry. Rings and pendants that change color with voltage application. Phosphorescent silver jewelry. Glows in the dark using embedded luminescent materials. Holographic silver jewelry. reflects iridescent light for futuristic aesthetics. 5. Hybrid metal jewelry, silver plus high-tech materials. Silver carbon fiber jewelry combines strength with lightweight design. Titanium silver alloys, more durable and tarnish-resistant than traditional sterling silver. Graphene-infused silver, ultra-strong flexible silver that conducts electricity for smart applications. Conclusion: the future blends tradition and innovation. Silver jewelry continues to evolve from ancient royal adornments to cutting-edge smart accessories, while handcrafted silver traditions remain cherished. The future of silver jewelry includes AI 3D printing, wearables, and sustainable materials.